One of the interesting things that we can do with logarithms is expanding and condensing. And at first, it seems like this is a silly skill, but when we get into solving logarithmic equations, it is very helpful to know these properties so that we can condense logs together and then go through the process of solving the equation. So right now, it's kind of theoretical. We're just practicing the skills. Eventually, we will use these skills to help us solve equations. There are three properties of logarithms that are helpful for expanding and condensing. The first one, if there's multiplication inside the logarithm. So do you see how this is log base b of u times v? That will expand to log base b of u plus log base b of v. Multiplication inside the log expands to addition between the logs. You use the same log with the same base for both things. You just take that u and v and split them up into their own logs and connect them with plus. So if multiplication means that we connect them with plus, what do you suppose division is going to make us connect the logs with? Multiplication and division are like opposites of each other, so what's the opposite of addition? Subtraction. So this would be log base b of u minus log base b of v. So does the order matter? In the first one, you could do log v plus log u. The order does not matter. But in the second one, because the v is on the bottom of that fraction, the bottom of that division, the v log must have the minus in front of it. So that minus is going to go with the log that has the v in it. Our last property is if you have an exponent inside the log, that exponent is going to move out in front, and this will become n times the log base b of u. We don't want to keep exponents inside the log. They can be confusing and messy. It moves in front and becomes multiplication in front of the log. Okay, so expand the expression. We can do this the long way, showing every single step. If we wanted to, we could show every step and then write a reason, like a proof. But seeing all of my students look at me with panic in their eyes, I think I'm going to avoid that word. So we don't have to write proofs. I'm not going to make you write log proofs. But if we want to do this step by step by step, I'll do the first one step by step, and then I'll show you how I do it a little bit faster. So I see the division. I'm going to deal with that division first. So this is log base 2 of 7x cubed, the top, minus log base 2 of y. So that division is going to split it up into 7x to the third is in one log, y is in the other log. Because the y is on the bottom, the minus is going to go along with that y. So whatever's on the bottom, there needs to be a minus in front of that log. Then we keep going. This 7x to the third needs to be split up. There's multiplication in between that. So we have log base 2 of 7. What symbol should I use to split these up? Plus log base 2 of x to the third. And we still have minus log base 2 of y. So far, we split up the division using minus. We split up the multiplication using plus. Now we need to deal with this exponent thing. I just made that kind of hard to read, didn't I? So the exponent thing, this exponent is going to move in front of that particular log. So that's going to be 3 times the log base 2 of x. We still have everything else. Log base 2 of 7. And we still have minus log base 2 of y. Okay, would you like to see how I do that problem faster with fewer steps? Okay. When I am expanding, I know that there's these three properties. There's a property involving multiplication, division, and exponents. So I'm going to look inside the original log and see how many things I have in there. I have the 7, I have the x to the third, and I have the y. There are 3 things inside that log. So I'm going to have log base 2 of something, log base 2 of something, log base 2 of something. I know there's going to be 3 logs because there's 3 things inside that original log. The first thing is 7. The next thing is x to the third. And the next thing is y. Okay. Anything that was originally on the bottom, that log is going to be negative. So because the y was on the bottom, the log that has that y is going to be negative. 7 and x cubed were on top, so that is going to be plus. They're just multiplied together, so that's plus. And then my last step is to look for any exponents and move the exponents in front to get my final answer. So I still end up doing 2 steps here. I write out the 3 logs, I put the stuff in it. My final step is dealing with any exponents, but it just helps me to get there a little bit faster instead of writing like 3 or 4 lines. I can write 2 lines and be done. So then this is our final answer. Number 2, do we want to do the long way or the shorter way? Shorter way? Ooh, I lost number 2. Okay. How many things are inside this log? There's multiplication, so there's the 25, there's the x to the 6th, and there's the y. So there's 3 things in there. So I'm going to write out log base 5, leave a blank, log base 5, leave a blank, log base 5. The first thing was 25. The second thing was x to the 6th. The third thing was y. Okay. The next thing I always look for is, was there anything on the bottom? Was there anything that was being divided, because that needs a minus in front of it? Do we have anything that was divided? No. So these are all going to be connected with plus because they were all being multiplied together. Then the last thing I look for is exponents. And I see this exponent of 6 right here. It needs to move into the front. So that term is going to be 6 times the log base 5 of x. And everything else stays the same. Now, technically, this problem isn't done because 25 is 5 squared, but that's just silly extra. I'm not going to make you look at that. Okay, do you want to, I feel like my number 3 isn't complete. What is number 3 supposed to say? Yeah, there's supposed to be an x in there. Do you want to try number 3 on your own? Sure, try number 3 on your own. So the 1,000 and the x squared were on the bottom. Those logs have minuses in front of them. The log of 9 is positive. You always, there's just always a plus in front of it. And then log of y is going to also be positive. Then we look for exponents. This x squared needs to move in front. So my final answer would be log of 9 plus log of y minus log of 1,000 minus 2 times the log of x. I put some extra information over here. Technically, 9 is the same as 3 squared, so you could replace 9 with 3 squared, and then that would create this expanded log. 1,000 can also be written as 10 to the third, which would make this be our final answer there. So I put technically we probably should simplify those even more, but I mean, seriously, come on. So I am not going to give you any that are that complex on your assignment or on your test. So I want to show you that you can simplify this a little bit more, but I'm not going to give you any that are that crazy. Okay, do you feel a little bit more comfortable with expanding now? Okay, everything we do in math, there's a way to undo it. So if we know how to expand, the next step is to condense. So now I'm going to give you the answers that we just got, and we're going to go backwards to get to what we started with. And I really should change these examples. I don't love these examples. Okay, so the first thing that we're going to look for is the last thing that we did previously. I'm going to look through here for numbers that are in the front, because this 2 in front of the log 2, that used to be an exponent. So I'm going to make that log of 2 squared. Then we know that this is going to condense down to just 1 log. So I'm going to write log. I see that there's subtraction in there, so that means that this problem is going to have division. Because the minus is in front of this log, that means the 3 is going to be on the bottom. So the 6 and the 2 squared are going to be on the top, multiplied together. Okay, those of you watching the video, yes, we could actually calculate 6 times 2 squared divided by 3. I think, what did I say the answer was? 8. Technically, this would simplify down to the log of 8, but I want you to practice the properties, not so much get lost in the math of finishing it. So I'm going to ignore that actually is log of 8 and just say that green thing I just boxed is the final answer. Okay, number 5. First thing we need to do is look at the numbers in front. So this 2 was originally an exponent. The 5 was originally an exponent. So we have log base 3 of 7 to the 5th. And we have log base 3 of x to the 5th. I mean 7 squared. And then x to the 5th. Do you think you can finish that one on your own? Give it a try. Once you've moved the exponents back into their place, the x to the 5th is on the bottom because it has a minus in front. The 7 squared is on the top. So log base 3 of 7 squared over x to the 5th. If you wrote log base 3 of 49 over x to the 5th, that would also be correct. Okay, I want you to pause the video and try number 6 completely on your own. Did you pause the video? For some reason, I feel like you didn't pause the video and you're just waiting for me to do the problem for you. I think you should pause the video and try it on your own. Like, seriously, pause the video. I mean it. I mean it. Do it. Okay, if you've lasted this long, then I guess there's nothing I can do. All right, the first thing that I do is look for numbers in front. So this 2 was originally a square, and I even get to the point where I just kind of do it like this so that I don't have to write a whole lot. This 3 was originally an exponent of 3. Then I know it's going to be log base 8, and I see subtraction, so I know there's going to be a division bar in here. The 5 has to be on the bottom. The y cubed has to be on the bottom because both of those have minus in front of them. And then the x squared the x squared doesn't have a minus in front. It's the first one, so it's got a plus in front because if there's no minus in front, that means it must be a plus, so the x squared goes on top. Log base 8 of x squared over 5y to the 3rd. On your assignment today, the first part of it is change of base, which we've talked about several times. So I'm just going to write down here, remember, if you've got log base b of u, you calculate that by doing log button u divided by log